Hi, welcome to this video tutorial. Today we are going to perform exploratory data analysis using Pandas library. EDA is very important in any data science, analytics or the machine learning project. So before going into deep, let's understand that what we are going to cover in this video. So first we will go for the basic data understanding and then for the data preparation and the cleaning, then move to the main important part of the analysis, that is the univariate analysis and the bivariate analysis. Then we will do some questions on our data set. So just look that what different things that we are going to perform here in data preparation and cleaning. You will do a lot of things you can see here. And in the univariate analysis, we are going to plot different types of the plot graphs and the plots. You can see here box plot, KD plots, violin plots. The bivariate and multivariate analysis, we are going to perform different types of the plot, and we will understand the meaning and why we are going to perform these type of the plots. So you'll see scatter plot is there, pair plot is there, and the correlation matrix we are going to perform the heat map, box plot for the categorical and numeric values. Okay, violin plots, line plot for the time series data analysis, and we will also see the crosstab, group by, and finally we are going to perform some questions here. I will upload this notebook on the GitHub and the dataset also. So let's get started. So let's go to the project folder and open the terminal, and let's open the Jupyter notebook. Let it open. So you can open here a new notebook like this, or just use already created notebook. So I'm going to open already created notebook here. So I have written all the things here that whatever we are going to perform. So let's first understand that what is EDA, Exploratory Data Analysis. Basically, EDA is to analyze and investigate the main characteristics of the data set. And while doing these analysis, we are going to use different types of the visualization methods. So there are different steps that we are going to perform. The first step that we have to go with, that we are going to understand the basic of the data. So first, let me show you the data set that we are going to use. So this is weather data that we are going to use. So let's go to our notebook. So let's first import pandas and other libraries. So control enter or shift enter. Now we have imported our libraries and packages. Now let's load our CSV file as pandas data frame. So what we will do, data frame we are taking as pd.read_csv, and we are going to pass the, so paste here, and let me put R here, control enter. Now our CSV data is stored as a pandas data frame. You can check as DF, so you'll get like see first 5 rows and the last 5 rows here and different columns. So we'll move to the next, do some basic data understanding. So we are going to perform all these things one by one. So let's first do data frame shape. So we can find data frame dot shape. So this data frame or this data set has 161 rows and 10 columns. Now one head and tail is there. So we can find the first rows of the data set using this head function, and you can put like 10 here, so it will give you first 10 rows. Likewise you can get 15, so it will give you first 15 rows. Okay, same way you can find out the tail also. So data frame dot tail you can do, so it will give you last 5 rows of the data. So now let's understand about the data type in our data frame. So you can write DataFrame dot d types, and you will get the different column names and the respective data type. The next is dataframe.info, that it will give you little more information about the data frame. So you can find here that 161 entries are there from 0 to 160, and from 0 to 9, 10 columns are there, and different column names are there, and the non-null entries in different respective columns. Okay, so you can find different things here about the data set, about the data frame. Let's move to the next function, that is dataframe.describe. This will give you the different information about the numeric columns only. Okay, so these are the numeric columns you can find here, and it will not include the object columns. Okay, object or the categorical columns. You can find that this column contains 161 counts, 161 entries are there, not null. Ozone has 123. So total entries are 161 and ozone has only 123. So this means some missing values are there. Okay, likewise solar also has some missing values, and you can find different things. Mean you can find. Okay, mean value for ozone column for non-null values is 41.8. Same way standard deviation you can find. Okay, so you can check that here has zero standard deviation. So this means there is no deviation from the mean. And here you can find that solar column has the maximum standard deviation. So this means the entries here in this column are very scattered away from the mean. You can find different things and interpretation. This is 25%, this is quartile 1, this is quartile 2, 50%, and 50% is basically is going to give you the median also, and 75% will give you the quartile 3. So this will give you a different statistics about your data. Here in this, the object columns, the columns, categorical columns are not included. So for that thing, you can use dataframe.describe, and within that you can give include equals object. It will give you, run this cell, some information about categorical columns. So temperature, C, month, and weather. So you can find how many counts in respective columns are, what are the unique, how many unique values are there, what will be the top value, and what are the frequencies. So let's move to the next, that is our data preparation. So this will be like data preparation, data cleaning part, and I have already created a video on data cleaning using Pandas. So you can check that also. So first thing, let me show you how our data set, how our data frame looks. So let me first check whether this dataset contains duplicate values or not. So data frame dot duplicated, and run this. You will get false and true. If false is there, so that means that particular row is not duplicated, and if true is there, so that particular row is duplicate. Okay, so to get particular rows that are duplicated, so you can use data frame dot log. Just run this one, and you can find that these three rows are the duplicated. So what we are going to do, we are going to drop these duplicate entries, these duplicate rows. So what we can do, we can do data frame dot drop underscore duplicates. Okay, and you can run this one, and you will get that now it has 158. Earlier it was 161. So after deleting, after dropping 3 rows, you will get 158. Okay, but one thing that you have to notice here, that it is 158 rows only, but it shows that 159 the index is up to 159. Means it does not reassigns the index values. So for that, what we have to do, we can do something, ignore index, ignore underscore index is equal to true. Okay, so you can do like this, just control enter or shift enter. You'll get here 150, you'll get here 158 rows, and from 0 to 157 indexes. Okay, so now this is good, and now we are going to assign the data frame after dropping the duplicates, and now you can check that how our data frame looks like. So now let's check that whether we are going to drop any column or not. We are going to check that whether any unwanted columns are there or any irrelevant column is there or not. So you can check here that unnamed, that is unnamed from 1 to 58. This is basically 1, 2, 3, that's index. So we don't need because we have index already here. Okay, so we can drop this one. And one thing that you can notice here that this temp C and temperature, that is 67, 67, 72, 72. This is in this is in string. All the entries are in string because the data type is object, and here you will find that all the entries are integers. Okay, so these two columns are basically the duplicates. Okay, so we can drop this column also. So what can we do? We have a function drop. So data frame dot drop function that we can put, we can give the, so in this function we can give the column names. This is unnamed 0, so we are going to put like this, and other column name that we want to drop is temp C. Okay, so you can put like this here, and if you check, so this may give you a problem. Okay, because what is the problem? That we have to put axis. What will be the axis? Axis will give you row wise or column wise. So we are going to assign as 1, means whole column we are going to drop. Okay, so run this one. Now you can find that unnamed, this one, and temp C, these two columns are dropped from our data frame. So let's assign to the original data frame like this and run again. And you can check that how data frame looks like. Yeah, so we have dropped irrelevant columns. Now let's move to other part, that if we need any renaming, so any renaming, if you want to rename the column name, so how can you do? Okay, so just one, this solar.or that we want to rename. So what can we apply? Data frame dot rename here. Okay, and you can pass a dictionary of old name and colon with a new name. Okay, so again that you have to pass that axis parameter, that will be 1 for the column wise. So we are going to perform this as column wise. So you can see here that solar.r is changed into only solar. Okay, so but you can check here that if you are going to find out, it will not be reflected in original data frame. So again we have to save, we have to assign into the original data frame and just print the data frame. So now you can check here that our column is renamed. Now let's move to the most important part of this, that we are going to deal with null values or the missing values. So how we can find out is there any missing value or not? You can use is NA and is null also, and just check that, run this one. So you'll get false and true. If true is there, this means the respective value missing. So let me put some here. You can find. So ozone column has 38 missing, solar has 7, and in this way weather have 3 missing values. Okay. So what we have to do, we are going to fill missing values by some value. Okay, it may be mean or medium or any other value. It depends on your data set. Without filling these NA values, you can perform exploratory data analysis also. So I'm going to fill one column and I will leave another column. So we have 2 columns here, 3 columns basically. I'm going to fill only solar, okay, so that it will not affect our original data set. greatly. So what we can do, just first find out the solar. So it will be something like that. It will give all the values and null values. Okay. So how can we do? We can fill this with mean. Okay. So we can find the mean value here. And if you go and check the solar, all the values are basically in point zero point zero. Means we are not going to take this much decimal part. So what can we do? We can round basically. We can use a round function to round, and we are going to check that 185.0. And now I'm going to use this to fill. Okay. So you can save somewhere and you can directly fill. So what can I do? Basically, I'm going to use this and dot fill NA. There is a function that you can fill the null values by some value. Okay. So I'm going to pass the mean here, and this will basically, so let me write here in another cell. First, let me run this one, and then let me check that what is the mean value display. Okay, so it's 185.0. Okay, now what I'm going to do, I'm going to fill this with this mean value. So after filling, you will get like this, that all the values are filled. So now this we are going to store, we are going to assign into this column value. Okay. So what you can do, you can write like this. So this will assign the filled column to the original column. And you can check here now our data frame. This is all the solar values are filled. So let's move to the month one and check that data frame, and this the unique values. Okay, so you can find here that there are different unique values. This month is basically object data type. Okay, so it contains the strings. So we have may here. So what we have to deal, so what we have to do, we have to deal with this. We have to convert may into 5. Okay, so how can we do? We can just use replace function. So data frame that we are going to use, and inside the month we can use and dot replace and function, and within that we are going to put a dictionary with old name and with the old name and new name. Okay, so here we are going to put the old, and here we are going to put the new. Okay, so you can find here that the old one is May, and we are going to replace May with 5. Okay, 5 as a string or the character, because this is a data, because this is object data type. Okay, so we are going to put as a, so after putting this, you can find here that all the, let's say that now how many unique values are there. Okay, now you'll get that 5, 6, 7, 8, 9. Okay, so what we have to do, basically we have to assign this to the data frame, original data frame. Okay, so what we can do, we can write like this, and we can assign like this. Okay, and check the data frame. So now you can check, now May is replaced with 5. Now almost our data set is cleaned, and we have prepared our data set for the analysis. But before that, we want to create a new column, a new feature, so that we can do something new analysis. That is, using day, year, and month, we can create a date column. Using that date column, we can perform time series analysis. Okay, so before that, moving to the analysis, we are going to perform this thing also. So what can we do? Basically, we are going to use data frame, and inside the data frame we are going to take these things, these part. Basically, I'm going to put first year, then I'm going to put the month, then I'm going to put the day. Okay, so I am going to create a date column that will be in this format: year, month, day. So you'll get like this year, month, day, and I'm going to convert this whole thing into what? Daytime data type. Okay, so pandas library will provide you a function to date time. How it will look like? So year, month, and day. Now we are going to assign this into a new column. Okay, so we are going to assign into new column that will be date column. Okay, so after assigning, you will check that this will also reflect in our main data frame. So just check that our main data frame. So you can check here, this date column is added at the end. Now another most important topic is basically outliers. So okay, whether we have outliers in our data set or not, just go for this. Just we are going to understand what are the outliers and how we can detect outliers. Okay, so for the outliers, the best thing that you can perform is box plot. Okay, so data frame dot you can plot box plot. Okay, and you have to put the column name that for that you are going to check. So let me go for the ozone one. Okay, and it will give you something like this. So these two data points will be treated as outliers. So from here to here, you can see here the minimum and the maximum limit for the accepted data points is from here to here, and these are the outliers. Okay, so most of the data points will lie within this range, something this and this. So for this thing, you can find basically, you can work basically with describe function you can get. Okay, so data frame, and for the ozone, if you are going with the describe function, so it will give you different things. So 75%, so you'll check this is the 75%, this value like 61.5. So 61.5 is 75%, and 50% is this one, that is the value 30.5. This is the median value, and that max is basically the maximum value available in our this column, and the minimum value is this one, that is the 1.00. Okay, so the value, to find out this limit, this accepted limit, we have to use these things, and let's understand what is the interquartile range. So from here to here, this box you can check from this box, so the upper limit of the box and lower limit, so between this whatever the range is, that will be our interquartile range. So the lower part of the box is 25%, and the upper part of the box is basically 75%. Okay, so you can find the interquartile range IQR, and that will be basically this one, 61 here minus that minimum point, not 25%. Okay, that will be our this one. Okay, and after that, let me write the max limit, this point to find the maximum accepted limit. So let's say max limit, it will be something like that, and that will be this point and the 1.5 times of interquartile range. Okay, so this you can check this one, and plus 1.5 times IQR. Okay, this will give you the range. This will give you the maximum accepted limit. This point is 126.75. So we'll use this limit, and we are going to find that what are the data points that are outliers. Okay, so if it is true, any particular row has true value, so that means that value is our outlier. Okay, so again you put here data frame, Now you can get these 2 points. Okay, so these 2 points you can check here for the ozone 135 and 168. So these two values are greater than 126.75. So these are the outliers. Okay, so let's move to the next step, that is univariate analysis. Okay, so univariate analysis is basically we are going to understand different features. So let me show you that how our data frame looks. So if you go and find data types, okay. So what ozone is float, and this is float, month is object, and weather is object, and date is date time. So whatever the things that we are taken here like weather and month, we are treating as categorical data, and others like float and int data types, we are treating these columns or the features as numeric features. Okay, so we will analyze in these two respect, categorical features and numerical features. Okay, so let's move to the first, that we are going to analyze categorical features. For analyzing categorical features, we can do different things like we can find the count, value counts, and bar charts. So let's move to first value count. Okay, so we are going to take weather column. Okay, for the weather and month, we can work on weather or month. So let's move to the weather. So how it will look, that weather. So you can check here whether has how many unique values or how many, you can find out how many unique values it has. So it has basically SCPC, and this is not available, not a number, and it has basically some missing values. So we are not going to deal with missing values. So we are going to find out the entries with respect to different categories like S, C, and PS. So when we talk here, we can understand the weather S as sunny, C as cloudy, and PS as partially sunny. So we can do one thing, that is value count. Value counts. This is the function that will give check that for the S 59 entries are there, for C cloudy weather at 49 and partially sunny. It's using these counts we can create a plot. Okay, so data frame gives us a plot function to plot different types of the plot. Okay, so in that what can we do, we can pass a parameter kind, the name of the plot. So we can create a bar plot for the categorical. So just run this. So for this thing, just we are going to put plt.show also here. So here you can find that whatever we have seen here, 40 59 or something for the S, and for the weather it was this is the frequency basically, that how many number of entries are there. Let's move to the numeric features that we are going to analyze. So for the numeric feature, we can analyze different parts, different things like mean, median, mode, variance, skewness. So if you go numeric feature, so let me put here like what we can do different things. So if you go data frame dot columns, you can find different columns. Okay, so ozone, solar, wind, these are the numeric columns. So we are going to take with let's say that we are going to deal with the winds. Okay, so you can see here the wind column has numeric values and float values. And one more important thing, same way that you can plot a bar graph for the month also, because month is also a categorical feature. So you can see here for the month also. Let's move to the numeric features. So in numeric feature, you can do something like that. What can we perform? One thing, that before going to any specific column, you can check that we already have done, that is describe. So you can check here, we can find different statistics here, like mean, and this will be the median and the max standard deviation and other things. So for this, just leave this one for the date column, that is not working properly on the date. And these things for the numeric, this is good one, that it will work for the numeric columns. Okay, so let's say that if you want to find out the variance, skewness, or kurtosis, so what can you do? So for the variance, data frame dot var, if you are doing only this thing, so it will create a problem, because we have in data frame different non-numeric features also. So what can you perform? So numeric only you can do here, and that will be true. Okay, so it will check for the numeric features only, and it will give the respective variance for the numeric features. Okay, so you can find here the year has 0 because there is no variance in it. Okay, obviously because only 1 year we have taken. And you can find here solar has the maximum value of the variance, and respectively the ozone is there. Okay, so you can check and you can find the intuition behind, you can find the distribution. Okay, and when we are going to plot distribution plot, you will check that what does these meaning. Okay, so now let's move. You can find skewness and kurtosis also. So like data frame dot skew you can put here, and again for this also you just put for the numeric is equal to true, and this way you can find, okay, this ozone is positively skewed and this is negatively skewed. So the distribution. Okay, we will check in the graph, in the plot, so it will give you little more insights. Okay, that what does this mean for the positive or positively or negatively skewed distribution. Okay, so let's move to the second part, that is our histogram or the box plot or violin plot. So we are going to plot different types of the plots for the numeric features. Okay, so one thing that you can do, so let's say that we are working with the solar or the whatever, you can check with different features. You can take ozone or wind or something like that. I'm taking here solar. Okay, and you can check the values and can put DataFrame dot plot, and within the plot you have to pass what kind of the data, what kind of the plot you need. Okay, so I need for this histogram. Okay, so just plot a histogram, and you can check. So basically we need to put plt dot show here to make it so this is the distribution histogram plot, the distribution of the solar data points. Okay, and you can check with different number of the bins also. I think the default is 10. You can use 20 and check. Okay, so you check that when we are taking 20 bins as 20, so how this will be. So what does bins means? All the rain from here to here is divided into 20 parts, and respective part, what will be the frequency, what will be the value of the data points that will come into this. Okay, so you can find here solar. You can check here that the solar data points are distributed very unevenly. Okay, they are very far from the mean. These data points are far from the mean, so this why the variance is very high. You can check someone that variance is very low, so that is basically day or wind. Okay, so you can check this thing for the wind also. So let me do again this for the wind. Okay, we can put here wind. Okay, and you can find, okay, for the wind somewhere the mean is here, and the most of the data points are near the mean, so the variance is less. So that's the case when the most of the data points are scattered around the mean, near the mean, so the variance will be less. So you can plot the histogram plots for the different features for the different columns. Okay, you can plot for the temperature also, and you can check different things. Okay, so let's move to the kernel density estimation. So that is basically you can find a similar way. It's very similar to this, but what is the difference? You can use here kind KDE only. Okay, and just remove the bins. So you can find here kernel density estimation plot. Okay, so this is somewhere that you can check that how this is. Okay, now let's move to the next type of the plot that we can plot for the numeric values, that I'm going to use box plot. And this box plot will take columns. What will be the column? That, let's say ozone, or anything else you can take. And yeah, obviously we have to give plt dot show here, because you know that this pandas plotting facility depends on the matplotlib library. So behind the scene, pandas use matplotlib library. Okay, so this is the way that you can plot, and you can, this box plot is very helpful in finding the outliers. So you can find here winds for the wind also. So here you can check that winds also contain some outliers. Okay, you can find for the temperature, so you can find here that temperature doesn't contain any outlier. Okay, so one more thing that I want to show you, that you can put here, this is vertically aligned, you can put vertical alignment as false. So what you can do, vert is equal to false. Okay, so you can put here and you can show, so it will give you like the horizontal way. Okay, so it will plot horizontally. Now let's move to some more different types of the plot, and one plot is basically using seaborn. That is very important. We can plot a disk plot. Okay, distribution plot. Okay, so distribution plot is very important. It will give you the distribution of the data, and basically this uses probability distribution function to plot. So how can we use? We are going to use SNS seaborn, basically that disk plot. Okay, so this disk plot, and we are going to give the data for this as data frame, and we want to put an x, basically what we need at x-axis. Okay, so notice that we are basically understanding, we are trying to understand one individual columns, individual features. Okay, so we are doing univariate analysis. Okay, so for the x, let's say that I am going to give here the solar column, and what kind of the things that I need, histogram. So okay, just plt dot show I need to put here. So you can find like this. Okay, exactly, this is the histogram. And what can we do? Basically, what can we do? We can put here KD also, so kernel density, the distribution also. So KDE is equal to true, sorry, and we can do like this. Okay, you can find this will be your KD and this is your histogram. Okay, so you can find histogram with kernel density estimation. Okay, so you can plot different type of the things. Let's now move to the violin plot. SNS you can use, and violin plot, and again for the violin plot also we have to put a data that will be our whole data frame, and x, let's say that x is basically our solar. Okay, you can put the data frame x as wind or temperature or any other feature. Okay, so plt dot show here, and you will get. Okay, so this is basically violin plot, and inside the violin plot you will get a box plot, and here this will give you the distribution plot. Okay, so for the solar, for the things for the solar, this is the distribution KDE, and this is similar way, this is the same distribution plot. Okay, now we have completed the univariate analysis. So now let's move to the important part of the bivariate and multivariate analysis. Okay, so in bivariate and multivariate, we are categorizing in different way, that we are going numerical versus numerical. So, and we are going categorical versus numerical and categorical versus categorical. Okay, so we will do different things, and we are going to perform also date versus numerical, that is basically our time series analysis, and we will do some grouped statistics using using group by. Okay, so let's move to this, and just we are going to plot a scatter plot. Okay, so we can use data frame. Okay, data frame dot plot, same, using pandas library, data frame dot plot, and we can give the kind equal scatter, and here we need two features. Okay, one on the x-axis, another on the y-axis. So for that thing, let's say for the x-axis we are going to put ozone, and on the y-axis we are going to put, let's say, temperature. Okay, it will look, let's see, and what other thing that I need to show this one. So this will be the plot, the scatter plot, and it will give some insight that how these two features, temperature and the ozone features, are correlated. Okay, so we can say that if ozone value is increasing, so temperature is also increasing, or vice versa, like temperature is increasing, so ozone is also increasing. So we can plot this for the different features, for different pairs of the features. And the same thing that we can perform using SNS, but let me show that it will give you a good thing, that it will be better using Seaborn. So in that we are going to pass data frame as data, and for the x-axis, same thing that we are going to use basically ozone, same thing. Let's take the same one, and for the y, we are going to take temperature. Okay, and plt.show. And this again same plot you will get. Okay, but what you can get, it gives us, so hue we can apply for we can use weather, any category, any categorical value here I'm using. So let's check that how it looks. Okay, so see here, the weather has these three categories, and with respect to these three categories, the colors of the data points are changed. Okay, and one more thing, that what you can do, you can use pair plot. Okay, so sns dot pair plot you can use to do this thing. So for the data, that I'm going to use as our data frame, and okay, you will check that how this pair plot will look first, and then we will make some modification if needed. Okay, so one thing that I want to remove from this, that is year. Okay, so this is not correlated or not related to any other feature, the year, because it is only, it contains only one unique value. Okay, so before that, let me do one thing, that I'm going to take a data frame, and I'm going to draw uh, from the main data frame this. I'm going to drop this one, and let me write like this, and I have to put axis equals 1, and I'm going to check that what this is. Okay, so you'll find I have deleted year from this. Date and weather, these will not work. Only numeric features will work here. Okay, so it will take only for the numeric feature. So I'm going to put here the data frame 1, and let's now check that how our pair plot looks. Okay, so now it looks better. Now it's look better. If you go with temperature and ozone, you can find there are some correlation between these two. You can find temperature. You can find temperature feature, how temperature feature distribution is, how this is day 1, and how wind distribution is. So wind versus wind, solar versus solar here, ozone versus ozone. Okay, this way you can find a pair plot. And one more important thing that will be good looking, you can also put here the hue, and you can give weather. Okay, and you just check that how it looks. Now you can check that the distribution is according to the categories of the weather column. Okay, so this weather column contains 3 categories, and our data distribution is in 3 different colors. Okay, so you can find the data distribution according to the category values. Okay, according to the weather category. Okay, so this is the distribution for one category, and this is green one is a distribution of another category. Here you can find out how your data points. Okay, so this looks good, that you can analyze your data set, your numeric features in one graph. Okay, in one graph, you can analyze different features. Okay, temperature versus solar, you can find here. Temperature versus wind, you can find here. This temperature and ozone is positively correlated. Okay, this is very good plot that you can find the distribution of different pairs in one plot. Okay, now this way we are going to work on the correlation. You can use dataframe.corr, and again I'm going to use numeric only, because so we don't need non-numeric features and non-numeric values. Okay, so let's run this, and you will get that the correlation between different features. Okay, how the different features are correlated. You can find here, you can find that solar feature is correlated with ozone with 0.34 value. Okay, and you can find which two features are highly correlated and which two features are positively correlated and which two features are negatively correlated. Okay, so these two features, ozone and wind, are negatively correlated. Okay, you can plot this correlation using seaborne heat map. So SNS dot heat map you can use, and you can give this whole correlation matrix inside it. Okay, and then you can use plt dot show. And one important thing that we can do here, that annotation, and annotation basically annot is equal to true. So it will give you the respective value, like ozone, this is 1 and this is 0.34, this is minus 0.59. So this is the other way to visualize the correlation between the two features, two numeric features. Okay, solar, how solar feature is correlated with this temperature, like positively correlated with 0.26. Okay, so up to here we have analyzed numeric versus numeric features. Okay, now let's move to analyze numeric versus categorical. So if a feature is numeric and another feature is categorical, so how can we do? Okay, so let's move to the one type of the plot that we can use, a box plot, SNS dot box plot. And in that box plot, basically we can put the same thing, that is data is equal to your data frame, and x will be something like, let's say that numeric value, and y should be a categorical. Okay, so let's say ozone is there and y is our a categorical, that is weather. Okay, so now let's plt dot show that you can see here. Okay, so you can find here that there are two different points, data points, that are outliers here, and that fall under S category of the weather feature, and this point falls under the PS of weather category. Okay, so you can plot, you can find, you can plot these plots, whatever the plots we have plotted, like box plot, violin plots, or the different other plots for the numeric features. We can plot those features for the numeric versus categorical, or categorical versus numeric also. Okay, so you can work on the violin plots and histogram plots. So you check that these plots, and let's move to the another thing that is very most important, that is time series analysis. We have created a new feature that was date, so we are going to work on that one. So let's plot, basically a plot, SNS dot line plot. So in line plot we are going to give data frame. You can put like data as a data frame, and what x we are going to put the date feature, and y you are going to take any numeric feature. Okay, so y you can put any numeric feature that will be let's say temperature, and again you have to put the plt dot show, and you can, yeah, you can see here the distribution of the temperature with respect to dates you can find here. Okay, so one more important thing that you can put here, that is here, and you can put weather, and you can check that how it looks. Okay, so it doesn't look very good, but you can see the plot, line plot with respect to different category of the weather feature. So let's delete this and put it only this one. Now another important thing is that if you want to make some analysis between two category, okay, categorical versus categorical data, like we are going to use Crosstab. Okay, so this function will give you important things, and you have to put what two different series you want. Okay, so you have to put here the series. So it will give you, let's say, month. Okay, another series you are going to put here as let's say that will be weather. Okay, so it will give you this type of the value. Okay, weather, C, PC, and S. Okay, so these three categories weather contains, And month contains these categories like 5, 6, 7, 8. These 5, 6, 7, 8, the month value in string. Okay. So you can find that in the May month, what are the entries? What are the entries of what are the entries that belongs to cloudy weather? What are the entries that belongs to sunny weather? Okay. So different things you can find with Crosstabs. Okay. And another very important thing is that we are going to understand group statistics, how we can make group statistics using group by. Okay, so this you can apply on different features, numeric as well as categorical. So one thing is that data frame dot group by you can use, and let's say that I'm going to group using weather. Okay, so you have to write data frame dot group by, then you have to apply the column name. You have to put a function name that you want. Okay, let's say we want mean. Okay, this will create some error because of data frame contains some non-numeric values also. So we are going to here put numeric values equal true. Okay, so you can find. So this will be the weather. We are grouping the means of the numeric values of the numeric columns according to the category of the weather. Okay, so you can find here the temperature for the cloudy days. Okay, for the cloudy days on average was 77.7, and you can find the mean or the average of ozone for this category is 36.9. You can put the ozone and wind, whatever the column name or features name you want. Okay, so you can put like this. You can perform different functions here. Okay, so let's write just one more function that is basically describe. Okay, that you can use describe function. So describe, sorry, for the describe, you can find, okay, ozone and wind you are taking, and describe, as we already know, it will give you count, mean, standard deviation, other things. It will group by the category of the weather. Okay, so now let's move. We are going to ask some questions on our data set. Okay, so this is basically, let's say that if you want to find what will be the average values of the numeric features of sunny weather. Okay, what is the maximum wind speed during the July when the day was sunny? Okay, and when day was cloudy, when day was sunny, something like that. So we are going to basically retrieve according to the question. So let's first understand what is Boolean indexing. Okay, so let's say that let's look that out how our data frame looks like, and let's say this 41, and let's say that ozone is there, and I need that ozone should be greater than this 41. Okay, so it will give you false or true. If greater than 41, then it will give you true. If it is not, then it will give you false. Okay, so you can find like this all the rows that contains ozone value greater than 41. These are the rows that contains ozone value greater than 41. Okay, so you can see here this value is basically Boolean value, whether it is true or false. Okay, so this way we can use Boolean indexing to find out our data. Okay, and here you can also put, if you want to like sort these values according to the temperature or according to the day or wind value or something like that. So what you can put sort values. Okay, so you can put sort values, and there is a by parameter that you have to put. What is that? So by, let's say that we are going to put according to the temperature. So you can put here temperature. It will give you like temperature starting with the minimum temperature in this subset of the data, and the temperature is increasing, and all this is all the value that contains ozone greater than 41. Okay, so if you want, you can put like ascending is false, ascending is equal to false, false, yes. So it will give the maximum value temperature first, and then it will go lower value, lower value. So let's move to the question that we have, and put it something, what are the average values of the numerical features of sunny weather? So we need numerical features and sunny weather. Okay, so what we have to do, we have to find out the weather, and this weather should be equal to sunny. Sunny here we are representing with capital S. So you can put it and you can run it. So you can find that this will be true or false, true or false. Okay. So this Boolean indexing we are going to use to find out all those rows, all those entries that contains here S. Okay, sunny. So this will be all entry for the sunny category. Okay, in the weather column. So in that what we want, we need the average value for all numeric. So all numeric, so we can use mean here and you can put here numeric value as true. Okay. So you can run and you can find here, you can check that all the entry in ozone feature for S category. Okay. The mean is basically 36.9. And we have already done this basically here also. If you go and check that, uh, this was the thing. If you remove this one and you can check, so this was the for the sunny, it was 36.9. So you can go like this also, but if you need a particular answer, you can do like this. Let's move to the next question, that is basically what is the average temperature during the month of June when the weather is cloudy. So in month June and we need cloudy weather. So first we need the month as June. So you remember that this 6 represents June in string. Okay. So it will represent true, false. Okay. And other thing that what we need is basically, and the weather should be cloudy. Okay. So what we can do here, our data frame that will represent weather that is basically cloudy. Okay. So what can we do? We can write C here. So again, you can find, so okay, W we have written in a small, you can find like this. Okay. So where month is June and weather is cloudy, so it will give you true. Okay. So let's move to let's find the actual data frames. So let's find the actual data points and the rows. Okay. So you can put like this. And you can find that these rows contains weather as cloudy and month as June, both. Okay. Now what we need average temperature. So we need temperature here. So out of this data frame, we need temperature. So you'll get temperature only, these things. Okay. This is the indexes of the rows. These are the indexes of the rows, and this is the exact value. And now therefrom we can check that it's mean. We can find the mean value. Okay. So here you can find that it's the mean is basically 78.33. You can put here round also. So it will give you rounded value. So here another important question is there. So this is what is the maximum wind? The maximum wind speed during July when the day is sunny. Okay. So this is for the assignment. And I hope that now you can do this and you can find the answer of this. And I'm sharing the dataset and this notebook on the GitHub so that you can practice here, and I want to know what will be the answer in the comment. So this was the exploratory data analysis that we have covered. There are different advanced techniques that we have to deal while doing exploratory data analysis. So these advanced techniques I'm going to cover in the next video. So stay tuned for the next video.